Okay, in this presentation we're going to look at the normal approximation of the binomial distribution. So the question is as follows. In a large sample, 35% of voters, that's a probability value or a proportion, intend to vote for Party A at the next election. A random sample of 200 voters, which is the sample size or number of trials, is selected from this population and asked which party they're going to vote for. Calculate approximately the probability that 80 people or more in this sample intend to vote for Party A. Just two things to sort of pick up on there. An approximately means an approximation, okay? And probability of 80 or more, so the number of people being greater than equal to 80. Just sort of be able to sort of read through it like that. Now, in the first instance, what we have here is a binomial distribution, okay? And with n equals 200 and p equals 0.35. And what we're going to do there is approximate it with a normal distribution, okay, which I'll talk about shortly, mu and sigma squared, okay. So essentially what we have to do there is sort of figure out what mu and sigma squared are shortly. It's very straightforward, but we'll just come to that shortly. So essentially what we're going to do there is approximate the binomial distribution, x binomial with this instead. We'll go down here. Now, a big couple of things that we should do, and I have this marked out already, is that you should, first off, actually just to sort of justify it a little bit, and essentially just sort of say n is large. Okay. For the binomial case, that's really the key thing there. The Poisson distribution is a little bit different, but n should be large also. So, calculate approximately, if you like different textbooks and different courses use different sort of stipulations about when and where to use a binomial distribution, but you do the best you can. I think in this case we would not meet the criteria for a lot of textbooks, but we'll just keep going. You know what? Let's do it. Now, this is actually the more important thing I want to talk about here. This is the sort of thing you have to remember, the continuity correction factors. Now, there's 5 different cases here. And really what we have here is a pretty straightforward, that it's this case down here. Okay. Now, but essentially there's 5 different cases, and just no matter when you set up your question, and we have set up our questions fairly clearly, x is greater than or equal to 80 when we're dealing with the binomial. So when you use the normal approximation, essentially what we're going to do here, b for binomial, n for normal, essentially that is n is greater than 79.5. Okay. And okay, so just actually a remark, the binomial mean is NP, which is 200 by 0.35, which is 70. Okay. And the binomial variance is n times p times 1 minus p. Sometimes people write that as q. So that is 200 by 0.35 by 0.65. And that should equal to 45.5. Okay. So that's it. That's just how we do those calculations there. So if x is the number of voters in the sample for Party A, we have x as a binomial, and we're using the central limit theorem. Essentially, it's a large sample size. Yeah, actually, just sort of state that. Okay, using the central limit theorem for to sort of justify this. Actually, just use it in a sentence in your answer. We can approximately say that x is a normal distribution with mean 70 and a variance of 45.5, approximately. Remember, it's approximate. It's not going to be exactly the answer, but that's not the point. So, essentially what we do here is calculate a z-score. Okay, remember this is variance here. So essentially what we do here is bring down 70 there and the square root of 45.5 there. It's a standard z-score formula. This is mu. This is sigma. Well, it's actually the square root of sigma squared. So this is sigma squared. Get the square root of that, you got sigma, there we have there, 45.5. Now it turns into a standard z-score calculation, probability of z being greater than 1.408 If you're using a textbook, you might have to just do your best and use 1.41, like Murdoch-Barnes and stuff like that. And using the standard formulae and the standard definitions for calculating the probabilities corresponding to z-scores, you should work out with an answer close to 0.08. So that's it. The binomial distribution approximated by the normal distribution. We'll leave it there.